Hi everyone and welcome back to chemistry. This is Mrs. Hutchinson and we're going to continue with scientific measurements, but now instead of just simply counting significant figures, we're going to calculate with them. So do all four functions: addition, subtraction, multiplication, and of course division. So if you don't have your calculator handy, you probably will want it. So pause the video and go ahead and grab your calculator. If you happen to have it, you can just continue watching. So adding and subtracting with significant digits, it's pretty simple. The first thing you want to do is you want to take all the numbers that you have and put them into a column. Line up the decimal points, just like you would for simply adding numbers with decimals. Perform the operations according to order of operations. As you know, adding and subtracting are interchangeable. And then the answer should have the same number of digits past the decimal as the column with the fewest number of digits past the decimal. In other words, your answer must contain as many decimal places as the measurement having the least number of decimal places. So, our rule for addition and subtraction for significant figures is we round to the least number of decimal places. And I typically abbreviate it DP. So here's an example. Let's just say we're trying to perform the operation of 16.1, 2.21 plus 7. We add them all up. Hopefully you can do this one in your head. It's not too bad. You get 25.31. If we take a look, though, our first number, 16.1, contains one decimal place. This number right here, this one, is our decimal place that we're looking at. It contains one decimal place. 2.21 contains two decimal places, so two numbers past the decimal. And 7 contains 0 decimal places. So 0 numbers past the decimal, which means our answer must contain 0 decimal places. So if we do our normal rounding rules of 25.31, we take a look at our ones place because that's the last digit that we're going to need for this, since we're going to have no decimal places. Look at the value behind it. If we round up or just leave it, so 3 means that we're going to leave it, so we're going to round to 25. Okay? Trust me, we're going to practice this. So it's not too shabby. So, let's go through these examples. Again, typically you want to line them up so that you can see all of the decimals, but it was just easier to fit it onto this page like this. So, let's go through this. 21.2 contains one decimal place. 32.5 contains one decimal place. 25.0 also contains one decimal place. And 18 contains 0 decimal places. So taking a look at all of that, our answer must have 0 decimal places for rounding. We calculate this out in our calculator or a brain, because this one's not that bad. 96.7 is what our calculator spits out, or our brain spits out. And rounding to 0 decimal places, we're going to take a look at our ones place, look behind it. So yes, we're going to want to round up. So we get 97 as our answer. If you're feeling pretty good about this, go ahead and try the rest of these on your own. If not, sit tight and I'll talk you through them. So we take a look at B. 12.88 has 0 decimal places. 69.25 has 2, so we want the least number of decimal places, so our final answer is also going to have 0. We do this calculation and we figure out that when we do this, it's 1218.75. Our answer should have no decimal places, so what we're going to do is we're going to take a look at our ones place here. Look behind it. We have to round up, so our answer is 1219. Next one, we've got 3 decimal places. 7.4 has 1 decimal place. 0.68, 2. And 12.0 has 1 decimal place. So our final answer must contain 1 decimal place. We calculate this out, and we find out that it is equal to 26.281. Our answer should contain just 1 decimal place, so that means that we're going to look at our ones place. That's a lie. Our tenths place, I apologize. We look behind it, see if we have to round that value up or down, and we do. So 26.3 is our answer. Moving on to the next one. We've got 1 decimal place, 2 decimal place, and 3 decimal places, so our final answer must contain just 1. Do all of our calculations, and it comes out to 4.42. So we have to round this to simply 1 decimal place, so that means that we look at our 1 decimal place, or our tenths place, that's the 1 place after the decimal. Look behind it, and we get 4.4. So let's see if we can't speed up this process a little bit. Next one. So we have to round to simply 1 decimal. So we've got 0.464. Rounding that, we would get 0.5. Our final answer should have 1 decimal place for the next one. Calculator spits out 4.4168. We're going to round that to 4.4. And then last but not least, we should have 2 decimal places for our final answer here. Our brain, this one's not really hard at all, it's 27.001, so we round it to 27.00. And by 27.00, I mean you can't read it, so it's 27.00. Boom. Okay? So that's addition and subtraction. Multiplication and division is a little different. So instead of rounding to the least number of decimal places, we're now rounding to the least number of significant figures. So you're going to perform the operations just like you want to. And then the rule for this one, for multiplication and division, is you round to least number of sig figs. So here's our example. We've got, say, 19.2 times 1.3. 19.2 contains 3 significant figures. If you forgot how to count significant figures, take a look at the last video. 1.3 contains 2 significant figures, so our final answer must contain 2 significant figures. We plug this in, we get 24.96. So rounding appropriately, 24. So this is going to be our last digit that is significant. Looking behind it, we have to round to 25. So addition and subtraction, rounding to the least number of decimal places. Multiplication and division, rounding to the least number of significant figures. So let's take a look at this. We're going to try and cruise through this as quickly as we possibly can. And if we've got 2180 and 14.825. So 2180 has a total of 3 significant figures, because the decimal is absent. 14.825 has a total of 5 significant figures. So if we're rounding to the least number of significant figures, our answer must contain 3 significant figures. We plug this into our calculator, and our calculator spits out 32318.5. So now here's where it gets a little tricky. You want to make sure that you keep zeros in as placeholders, because if we round this to 323 is nowhere near 32,318.5. So you want to make sure that you are maintaining those placeholders. Okay. So we count out our significant figures that we want in our answer. We want 1, 2, 3. So we take a look behind that value. We see if we should do any rounding. If we should round up. Nope, we shouldn't round up. So we get 32,000. And then this is what I mean about keeping those zeros here. You want to keep those as placeholders because 32,300 is very close to 32,318. A lot of people just say, well, we need 3 sig figs, so I'm just going to make it 323. You can't do that. That is not even remotely close to the number that we're looking to round. So make sure that you keep those zeros in there. Next one. If we take a look, we've got 3 sig figs and 4 sig figs. Our answer must contain 3 sig figs. Our calculator spits out 4.4563. So then we count 1, 2, 3. Take a look behind it. And we're going to round up to 4.46. Take a look at the next one. We've got 5 sig figs, which is a lot, and 4 sig figs, which is, well, still a lot. So our answer is going to contain 4 sig figs. Our calculator spits out this gigantic number of 35.73078, and it just goes on and on and on. So what we're going to do is we're going to count out our 4 sig figs that we need. 1, 2, 3, 4. Take a look behind. Do we have to round? Yay or nay? We do not. So it's 35.73. We don't have to round up at all. Next one. We've got, again, quite a bit for our significant figures. We've got 5. We've got 1, 2, 3, 4, 5, 6, 7, 8 significant figures. Our answer must contain then 5 significant figures. We do this out and our calculator spits out a gigantic decimal of 3.0770775. I need to zoom out a little bit. 5, 7, 4. Holy cannoli. So we then have to count out our significant figures. So we've got 1, 2, 3, 4, 5. Take a look behind. We have to round up, so it becomes 3.0771. Boom. There's our answer. I'm going to just go through the next ones kind of quickly. So we've got 5 sig figs here. We've got 5 sig figs here. So our answer, it comes out to be 29,650 is exactly what our answer is. However, if you take a look at that number, it only contains 4 significant figures, right? Because the decimal is absent. So if we take a look, that number only contains 4 significant figures. However, we need to have 5. So Best way of doing that is to add a decimal right here. By adding that decimal, we now have made that 0 significant, and our final answer contains 5 significant figures. So you've got to add that decimal. Next one is a little tricky. Our calculator, I know I said I was going to try and go through these quickly, but I forgot how tricky these ones were. Our calculator is going to spit out an answer of 301.3. We've got 3 sig figs for 131 and 2 sig figs for 2.3. So, well, you count out 1, 2, look behind, don't have to round, so it becomes 300. Well, how do we make 300 have just 2 significant figures? I mean, it's got 1 now because the decimal is absent, but if we add that decimal, if I can, there we go. If I add that decimal, suddenly all of them are significant. So we go from 1 to 3. So now, what are we going to do? Well, best way to go about this, when you just want to make it have a certain number of significant figures, you can put it into scientific notation. Remember scientific notation, all the numbers that you have prior to your times 10 or factor of 10, those are all significant. So 3.0 times 10 to the second, that means that this 3 and this 0, those are both significant. So now we have 2 significant figures like we wanted. That's how you would go about doing that. And last but not least, I know there's a lot of writing on this page, but the very last but not least, we've got our final answer. We've got 3 sig figs here. We've got 3 sig figs here. Therefore, our final answer should have 3 sig figs. So we're going to have our final answer of 2.73. Okay? Lots on that page. So the question is really, well, why do we have to even go through all of this? It's just a number. Well, knowing how many significant figures there are in direct measurements basically help us determine if the correct precision to use for our certain calculated measurements. Because we can't have an answer that's more precise than the instrument that we're using. It's just one of those things. So, now what I want you to do is take a look at this particular worksheet. Make sure that you pay attention to what operation you are doing. Fill out the first 2 sections. Those are definitions, so fill those out. I'm not going to do that for you. But when you're adding or subtracting, how do you round to the appropriate significant figures? And then multiplying and dividing, how do you round appropriately? So taking a look at our first one, we have 2.0 times 0.2. So, again, this may help you figure out the definitions above, so just pay attention if you will. So 2.0, because it's multiplication, we want to round to the least number of significant figures. So we've got, that's a blatant lie, we don't have 2. We've got 3 sig figs here, and we've got 1 sig fig here. So that means that our answer must contain 1 significant figure. So our final answer for this is going to be 0.4 centimeters squared. Okay. The next one, because we're dealing with addition or subtraction, in this particular case addition, we want to count our decimal places. So we've got 0 decimal places here. We've got 1, and we've got 1. We want to add them all up and it happens to come out to a nice and even value, 41 grams. We don't need to add any decimal places because we should have no decimal places in our answer. Okay, so go ahead and try this worksheet, and then I will see you in the next video.